Now let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1000. Hopefully you guys had a good week. You had a good weekend prior to this. We had our first test on Monday, just in time for midterms week. So that's what we'll be going over today. In other news, you should be completing lecture 14, I believe, today. So make sure that you get to that at some point, at least some point before the next class. So next week, there are no quizzes, so you get a break. You know, midterms week is very stressful for everybody. So next week, just relax a little bit. But for now, let's actually go over the test that we just did. So there's a lot to get through. It was a hefty test, of course, a 90-minute test. And so let's actually just jump in. So the plan is just for me, there we go, sharing the screen. The plan is just for me to go through, make sure I can see the chat here. So I'm going to go through the test essentially, showing you guys what the answers are, why they're the answers, and basically you can just stop me if you miss anything or you disagree with anything or you're not sure why something is. The grades aren't out yet. So I gave you a tentative date for Monday. I believe they should be done some point tonight or tomorrow though. So yeah. So remember, there are parts to the test where I had to actually I don't think so. Not more than has already been inputted. Like you'll notice that the class already has kind of a curve built in. So usually whatever you see on Jupyter grades right now is pretty much what it would be in general. So after I update Jupyter grades, you'll see where you are. And that would be after any curve is put in or anything like that.
I have a question.
Okay. Yes.
Is there any better way we could upload our work during the test? Because I had to email myself the answer, my work, and then upload it because my two devices weren't connected. So that took time. So is there a better way I can do that?
There are many better ways. You can log in on your phone, and if you press the upload button, it'll link directly to your camera, and you can just take a picture and upload directly.
So take the test on my phone?
Yeah, you can actually open the test on your phone. Okay. You can have it on the computer, but when you want to upload your work, just log in on your phone and upload the picture directly from your phone.
Okay, thank you.
That's pretty quick, and that would avoid you having to email stuff to yourself and all that sort of things. So you can actually log in on your phone while you're reading things from the computer, and just so once you're done writing, you just use your cell phone, take a picture, upload, start working on the other problem, and yeah, you won't need to actually transfer between devices. Yeah. So yeah, that's probably that's the quickest way I would say to do it, to just log in with your phone itself. And when you press upload, it'll give you the option to actually use a picture from your gallery or use a picture that you will take in the moment. Okay, that being said, let's go. We're going to go through the test. I'll essentially just, to save time, just essentially just go through it pretty much on my own, but you can stop me if you have any questions. Okay, so problem 1, reduce to lowest terms. Okay, so we know or should know the trick for this. The idea is to factor the top and bottom. So I'll call this F. So F is equal to, I want to factor the top and bottom and see if I can cancel common factors. And hopefully these guys factor. To get a 60, 6 and a 10 should be able to work. If I make it a -10 and a +6, that gives me the right middle term. For in the denominator, for a 12, to get to a 4, 6 and a 2 would work. And if I make it a +6 and a -2, that works out. So these guys would cancel. And so I would end up with x -10 over x -2. That's the fourth option here. Okay, so that is the first one. moving on. So this is another one where very minimal calculations are needed. You want to rationalize the denominator. Just realize that this is difference of cubes. So you should be thinking of how can I cube the first guy? Well, I know that if I multiply by something that looks like this, that would allow me to cube the first guy and cube the second guy. And so that's what I want. I want something that looks like this, where my A is x to the 1/3 and my B is just 1. And it looks like this guy right here. So that's a problem type that we've spoken about several times before, what it means to rationalize something. So that shouldn't be too bad. Here, show your work. For this problem, you want to actually rewrite as a simplified rational expression as a single one. So you want to combine and simplify. Okay, so we know what that means. We need to create a common denominator. So we want to factor the denominator so we can see all the factors that we would need. This is a B. Now, of course, this one is missing the A plus B factor, so I'd multiply by A plus B. And then there's a +5. And this one is missing both factors, so I would actually multiply by an A minus B times an A plus B. In the numerator, I'll multiply it out so that it's easier to expand the parentheses later. So everyone here is over A minus B, A plus B. Remember, we never expand the denominators because we want to make sure that if anything cancels, we'll see it right away. So I would have the 2AB. Here, I would take the minus B and distribute it across the A plus B. So this is minus AB minus B squared. And this would be 5A squared minus 5B squared. So this is going to give me 5A squared. And I would have 2AB minus AB. And I would have minus B squared minus 5B squared. And I would have that. Let's make sure that I didn't miss anybody. So there's the 5A squared, 2AB minus AB is plus AB, minus B squared minus 5B squared is minus 6B squared. Okay, so that's actually the guy. No one looks like that, so probably it means that this guy can simplify further. So I'm going to see if this can factor. And we already saw the trick for factoring guys like this already. Essentially, just imagine that the B isn't there, and you just think of it as a quadratic in A. So just imagine it's like 5A squared plus A minus 6. So you would need a 5A and an A. To get a minus 6, maybe a 3 and a 2 would work. That would get me to the right thing. So maybe like a 3 here and well, no, that would give me 10 and 3. So no, that's not going to work. 6 and 1 can work. So I can do a 6 and a 1. So that would give me a 5A and a 6A. If I want to get a positive A, I would have to put a plus here and a minus there. And then you just attach the B afterwards. You'll notice that now these guys cancel. And so you would end up with 5A plus 6B over A plus B. That's this option right here. Okay. Moving on to problem 5. This is dividing two rational expressions. So we're going to do the whole keep, change, flip idea. So we're going to keep the first one. change this to a multiplication, flip the second one. And we also know that we want to kind of see if things factor and cancel to simplify. So first one, Z, 2 and a 1 seems to work, both positive. 3 and a 1 seems to work, both positive. For this one over here, 3 and a 1, only options out there, make this a +3 and a -1, that would work, give me a +2. Here, 2 and 1 are the only options. If I make this a +2 and a -1, that gives me the middle term of +1. And so now you just go through and you cancel. So these guys cancel. X plus Z plus 2 cancels with that. Z plus 1 cancels with that. Z plus 3, Z plus 3 cancels that. So it seems like everyone cancels out. So you end up with a 1. So that's that one. Okay, so here, these guys are polynomials individually. Polynomial. This is a polynomial. And these guys are work everywhere individually. And so the only problem is if the denominator equals 0. So here, I just need to check where the denominator equals 0. So I can factor out an x. This factors further. So this gives me x is 0, x is 1, or x is -1. So on our number line, I just have to avoid all of these guys. So I have to avoid this. But really anything else can work because these guys are polynomials otherwise. So between here. So from -infinity to -1 works, from -1 to 0 works, from 0 to 1 work, and from 1 to infinity works. So there are 4 things, and yeah, looks like that's that. And yes, the point of me asking you to show your work is also to make sure you know that what you're doing, you didn't just plug into a calculator, but also to give you partial credit if you overall have the idea, but you made maybe a silly mistake. You should get most of the credit and don't get everything wrong. Okay, here, evaluate the expression when x equals 3. Well, x equals 3 makes the denominator 0, which means the expression would be undefined. So none of the above. Divided by 0 never makes sense. It's not infinity. It's not something else. It's none of the above. So that one was more of a concept question than anything. It didn't require a lot of calculations. This one. Compute and simplify the difference quotient. Something very important in Calc 1. So you're going to actually extend this a little bit further in Calc 1. There's going to come a point where you're going to want to plug in h equals 0, which is why you need to cancel the h at the bottom. But I'll let your Calc 1 teacher tell you about that. For now, let's actually just get to this one. We know that f of x plus h minus f of x all over h, what is that going to be? So f of x plus h just means I go to the original. Everywhere I see x, I replace it with parentheses x plus h. So this would be 7 minus 6 parentheses x plus h minus parentheses x plus h squared minus parentheses, often forgotten, but very important, all over h. At this point now, I just want to clean up here. So I'm going to expand parentheses. Here, don't distribute powers across sums. The x plus h all squared expands to x squared plus 2xh plus h squared. And then I distribute the negative sign. So it's minus x squared minus 2xh minus h squared. Expand the parentheses here. And I get that. Now let's see who simplifies. So minus 7 and plus 7 go away. Minus 6x plus 6x gone. Minus x squared kills the positive x squared gone. So we are left with minus 6h minus 2xh minus h squared all over h. Can't cancel across sums, therefore I will factor out an h. And these guys cancel. And so I get minus 6 minus 2x minus h. And that's the last option here. Okay, factor this completely. So this is already kind of half factored, but you need to make sure that each factor can factor further. So what I would do here is if I pick up from, this is the guy I'm focusing on. I want to factor that. Notice there's a common factor of 4 in the first one. So I can factor out a 4, I'd be left with 4x squared minus 1. I can also factor out a common 4 in the second parentheses. This will leave me with 3x squared plus 4 into that goes what, 7? Plus 2. So this is 16, the 4 times the 4. This here, I would actually write it or think of it as 2x squared minus 1. So I can use the difference of squares. And here, this is 3x squared plus 7x plus 2. So I would factor this out. This would be 2x minus 1 times 2x plus 1. And this here, the last parenthesis would be like a 3x and an x. I need a 2, so it has to be a 2 and a 1. If I put a 2 here and a 1 here, and if I put additions, that would actually give me what I want. So that's the correct factoring. And that's none of them. Now here's a problem we saw, a problem type we saw before. It's been on a couple quizzes at this point. So we know when we see a situation like this, The trick is they expand the parentheses on the left, bring everyone to one side, factor, and apply the zero factor property. Okay, so that would be the strategy here. Expanding the left would give me x squared plus 4x minus 12. This would give me x squared plus 4x. I would add 7. That would give me a minus 5. And so I can have an x. It has to be a 5 and a 1 to get to the 5. But if I make it a plus 5 and a minus 1, that would work to get me a middle term of plus 4. So this means my x is minus 5 or my x is 1. So there we go. So that was the halfway mark. So are we still alive? Everyone's still there? So are we still breathing? Okay. All right. Ariel gave me the thumbs up. Angelina's like, yeah, okay. So at least 2 of you are alive. Someone else is coming in. I guess they were having internet trouble. Okay, so let's keep moving. So this may serve as a hint for the next problem, meaning you could do the next problem without even worrying about your answer here. But I think if you got the answer here, it would make the next problem easier. And this is a matter of the best thing to multiply by. We know that this is the LCD. So this here, someone else trickling in here. So this here, realize that if I were to factor the denominators y times y minus 1, minus 6 over y minus 1 times y plus 1 equals 0. And that kind of tells you that the LCD is y times y minus 1 times y plus 1. And that's this guy. So in this one, I asked you to actually solve the equation that was in the last problem. So if you went through the trouble of finding the LCD, this would be easier. But there are other ways you could have done it. You could have just created a common denominator right here on the spot, but you'd actually just be recreating the LCD. So because you already found the LCD, this is going to be a little bit easier. So we have the y plus 2 over the y times the y minus 1 minus the 6 over the y minus 1 y plus 1 equals 0. So this is the given guy. I just factored the denominator. And now what I can do is I can multiply this entire equation by the LCD, y times y minus 1 times y plus 1. This is the LCD found in the last part. So I would actually, I can take this expression here and multiply that and multiply that. So in the first scenario, the y times y minus 1 cancels. I'm just left with a y plus 1. So this is y times 2, y plus 1. Here, all of those guys, the y minus 1 and y plus 1 cancel. So I'm just left with the y equals 0. So now we're in a situation where there are no fractions to worry about. And we've been in this situation before. Expand everyone, refactor. So this is y squared plus 3y plus 2 minus 6y. So this is going to be y squared minus 3y plus 2 equals 0. This is going to be a minus 2 and a plus 1. Minus 2 and a minus 1. And so this means like your y equals 1 or your y equals 2. But we have to remember that this was a fraction that we cleared denominators for, so we might have messed things up. You'll notice that y equals 1 would actually make the original denominator 0. So this one is rejecting because you always check your work on guys like these. So here, reject, since it makes original denominator equals 0. The 2 works out though. So that'll be that guy. You'd realize that if you plug in 2, you get 4 divided by 2 minus yes. Did that the 2 work? Let's see. Let's make sure. Y plus 2 over y squared minus y. Let's be good and check. Let's not just assume that it works out. It's 6 over y squared minus 1. Y plus 2, y squared minus y minus 6 over y squared minus 1. Da, 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 da. That seems to be fine. Okay, so if our y equals 2, does this actually work? So this is 2 plus 2 over 4 minus 2 minus 6 over 4 minus 1. This would be 4 over 2 minus 6 over 3. This is 2 minus 2, which is 0. So yes, does work. So the 2 works, but the 1 didn't, because the 1 would make the denominator 0. So moving on to problem 13, lucky number 13. Another kind of problem that we've seen before. We kind of know how to do with this. So this is the original, the 2x plus 4 equals the square root of x plus 3 plus 1. To get rid of the radicals, we're just going to square, right? You have to square both sides. So square both sides. I will mention that a common mistake is to square squaring the terms individually. This is wrong. It's essentially a distributing powers across sums error. You must square both sides. You must square the entire side. Okay, so that would tell you that this part here becomes 2x plus 4, but that part here becomes the square of the first plus 2 times the product of those two plus the square of the last, right? But if you squared each term individually, you'd miss the middle term. Squaring individual terms would make you miss this guy here in the middle. Okay, but assuming that you were very good with how you want to approach these. You do want to square that. So now what we're going to do is bring everyone to one side. We want to isolate the radical now that there's just one left. So I want to, move the x over, move the 3 over, move the 1 over. So this side would become just x. This side would become 2 radical x plus 3. And we would do the same thing again. We'd square both sides. So this is x squared equals 4 times x plus 3. Another common error is to forget to square the 2. Right? This 2 needs to be squared to give you that 4. Okay, so here we would have x squared equals 4x plus 12. We know how to deal with that at this point, hopefully. Bring everything to one side. We want to try to factor 6 and 2. So you have x equals 6 or x equals minus 2. Now you do need to check these because you're squaring. Remember, squaring will kill negative signs. So you want to make sure that you're not, like, by changing the sign, you didn't actually get something incorrect. So you're going to check x equals 6. Let me repeat this here. So if I check x equals 6, this part here is going to be the radical of 2 times 6 plus 4. That's going to be the radical of 12 plus 4. That's going to be radical 16. That's going to give me 4. This here would be 6 plus 3 plus 1. That'd be radical 9 plus 1. That'll be 3 plus 1. That'll be 4. So this one actually checks out. Now I would try to check the x equals minus 2. Which means if I plug in minus 2 here, this is 2 times minus 2 plus 4. That's just radical 0, which is 0. Here, if I plug in minus 2, that's just radical 1 plus 1. That's actually 2. So this does not work. This thing is getting working so well earlier. Okay, so this one does not check. So only 6 is the answer. Okay. And I just want to mention something here since I was doing this. This is one of those situations where some of these common mistakes will happen all the time. And I actually wrote these down. But I wanted to just stop right here for a second and talk a little bit about this because during office hours today, when I was talking to several students, this kind of came up about how to actually study to improve, like when you're practicing and you're not seeing any results and things of that sort. Sometimes what you're missing is this kind of analysis right here. actually figuring out what your errors are. So oftentimes what will happen is students will go through something, go through a problem, they get the wrong answer, they look it up in the back of the book, they get the wrong answer, like, okay, I got the wrong answer. And they, they just back to the drawing board, they crush up the paper and then they just start over. Or they go and ask for help and then someone tells them, okay, this is the way to do it. And they're like, okay, all right. But the thing is, when you study like that, you kind of miss the errors that apply to you. And so you'll tend to make the same mistakes over and over. So what you want to do is when you get a problem wrong, you don't just throw it away and start over. You want to actually go back to the work that you got wrong, the incorrect work. And you want to do something like this, use a different color ink, maybe to even make it stand out even more. And have whoever you're asking who's helping you, the tutor or whatever, to actually look over your work and not just say, oh, it's wrong and just start over, but say, no, specifically what line did I go wrong? What thing did I do that I shouldn't have done, right? And they would be able to point things like this out to you. Oh, you squared each term individually. You should have squared the entire side, right? And you would make a comment of that. Okay, my mistake was this, my mistake was that, right? So there are a lot of common mistakes out there. And when I'm teaching, I'll mention the most common ones, but really it's going to be personal, right? Different people will make different kinds of errors. And so you want to know the errors that you personally make. And that requires you to go through and you need to examine your personal work, figure out where your personal misconceptions are and deal with those and then really address them, right? And make it stick out, make it a big deal, make it like, you're right. So I know a lot of people don't like to dwell on their failures, but when it comes to learning something technical, this is actually important. You do want to know specifically where you went wrong and why you went wrong. You need to emphasize it, right? And so now that literally rewires your brain now to know to look out for that thing. Oh, last time I made this mistake. Now I know better, right? Like you'll now start to pick up on your mistakes instead of things like just happening in the background. Right. So, there are a lot of people, a lot of students, probably a lot of you who you have this opinion of yourself where it's just like, you know what, I get the math, but I just make silly mistakes on tests. It's my cross to bear. This is just me. Like when it comes to tests, I just make these silly mistakes and that I know better about. Right. So what happens when that happens? It's because you just kind of let your silly mistakes slide, right? Which is not what you want to do. What you want to do is whenever you make a silly mistake, you need to highlight it. You need to write it down. Here's a mistake I made, here in red ink. And you want to just dwell on that mistake and be like, okay, I tend to make the mistake that I square each term individually rather than square both sides. No longer I'm going to accept that as a silly mistake. This is now something that I'm not going to do anymore. I'm going to write it down. And so now when you're going, and you're doing a problem, whenever you make that mistake, it's going to come back to you because you actually made a big deal out of it, right? It's like your brain is now looking for this mistake. And so now it's like, oh, you're going to now avoid the silly mistake in the future, right? And it won't be, I'm just the person who makes these silly mistakes. No, you're going to identify those silly mistakes. And in your brain, they're not going to be silly anymore. They're going to be something that your brain is looking for. And it's going to be able to identify them more regularly. So that's a very important thing. So when you just say like, oh, I just made this silly mistake and you kind of gloss it over and you just mark off the whole problem as wrong and move on with your life, that doesn't help you in the future, right? You'll know that you got that specific problem wrong, but because you never really addressed the reason why you got it wrong, you're now more prone to just make the same mistake over in a different problem, right? You don't want that. You want to know, I got this wrong for this conceptual reason. And you can take that concept with you. And now every problem you do after that point, you know to look out for that concept. You'll know, oh, this is a mistake that I should be addressing, right? And that's how you kind of get out of this rut of, oh, I just make silly mistakes. All right, I always do that. I really understand more than my grade shows, but I just make silly mistakes. I drop negative signs and I do this. Like when you realize that you're always making these silly mistakes, even though you know better, you need to actually change things up. You need to stop thinking of them as, oh, it's a silly mistake, but no, make it important. Every time you make that mistake, write it down. This was the mistake I made. Why did I get this wrong? I got this wrong in line number 5 because of this mistake specifically. And now you're starting to look for it. And your next time you'll realize that when you keep this practice up and your brain just knows to look for this silly mistake, it's going to notice it in the future. Like whenever you're about to make it, you're going to notice, right? And you'll not make it in the future. So what I'm doing here when I'm highlighting in red what common mistakes are, you guys should be doing this for your own work individually. Everyone's paper, when they mark it up this way, is going to look different. Different people will make different mistakes at different times. But for you as a personal assessment to study and get better and to stop making the mistakes you always make, this is one of the main tips in actually addressing that. And I mentioned this to a couple of students in office hours this week. And so I figured I'd mention it to the whole class because it's a pretty important thing. I probably mentioned it before in passing, but I just want to stop here to emphasize it again. So that's a very important kind of thing. So now, if you guys are even looking at the work you were doing for the test, like if you saved your work and you're looking over it while I'm going through these, you should be noticing where does your work not match up to the work that I'm showing you? And then figure out what happened in this line. Why I was with Jhevon up to this line, but then I deviated here. Like what happened? Why was that wrong, right? So things of that sort, like that's one way you should study. So don't just gloss over problems in general when you get them wrong. Figure out why did I get that problem wrong? What line did I specifically get it wrong? What concept did I miss, which is why I got it wrong? What is the better concept to do? And you make a note of this in the margins. Okay, so ranted there, let's get back on track. So here's another problem. We have an inequality and there's an unknown part in it. There's an A, but we do know that the answer that we want. So this was just actually the main concept check here was, do you know what it means for an absolute value to be less than or equal to something, right? So if you actually knew what that means, which we went over in class, this one probably wasn't that bad. So what you would do here is, well, I have 2x minus 1 plus a is less than or equal to 10. Just isolate the absolute value, always a nice thing. So I would have subtract a from both sides. And now the thing is, I know what it means for the absolute value to be less than or equal to something. It means I can put the negative of that thing on one side. The thing inside the absolute value is in the middle, and then put that thing on the other side. That's what it means. It kind of branches off, right? So if absolute value of x is less than or equal to k, it means that minus k is less than or equal to x, less than or equal to k, right? So we did this in class. And so now you want to just isolate. So what you're going to do, so this is minus 10 plus a. I'm going to add 1 to all sides. And then I'm going to divide all sides by 2. Right? So I'm adding something and then I'm dividing by a positive number, so the inequality signs stay in the same direction. So here you'll notice that I have minus 9 plus a all over 2 is less than or equal to x, less than or equal to 11 minus a all over 2. And I know what the answer I want. It should be minus 3 and 4. So I know I want this to be minus 3. And we want this to be 4. So that leads to 2 equations that, of course, they have to agree with each other. If they don't, it means that there's actually no solution and it was like a none of the above or something. So I want minus 9. That minus looked very wiggly. So I want minus 9 plus a all over 2 to be equal to minus 3. And I want 11 minus a all over 2 to be equal to 4. Let's start with this one here. This means that minus 9 plus a is equal to minus 6. In other words, my a is equal to 9 minus 6, so my a equals 3. I'll try it here. So this is 11 minus 3 all over 2. Well, that's going to be 8 all over 2. That gives you 4. So that checks out. A equals 3. So this is what A has to be. A has to be 3. Okay, another one. As we saw with inequalities, clearing denominators is probably not a good idea. So you actually probably want to go back to first principles and combine the fractions. If you do clear the denominators, you just have to make sure that you are aware, which I don't recommend because students will forget to do it. But you have to make sure that you're aware that you have to avoid anything that would make the denominator 0. But here we kind of want to keep the denominator present so I can visually have that reminder that I don't want the denominator to be 0. So I can actually combine the fractions on the left. This is going to be 2 times x minus 3 minus x minus 4 all over x minus 4, x minus 3 is greater than 0. And I'm using just the combining, using the fact that I know if I have one fraction minus another fraction, I can take this as AD minus BC all over BD. That's what I did to combine these guys over there. Yeah, now keep going. This here is 2x minus 6 minus x plus 4. And this is going to be just x minus 2 over x minus 4, x minus 3. And so now what you do is you set top and bottom equal to 0, set top equals 0, and bottom equals 0. So this means you need that your x minus 2 equals 0, so your x equals 2. Here you need your x minus 4 times x minus 3 equals 0. So your x equals 4 or your x equals 3. So now you test these. So we have 2, 3, 4. Now we're not allowed to be 3 or 4 because they make denominator 0. So we have to avoid those. But we're also not allowed to be 2 because we have a strict inequality. So we can't be equal. Now I want to actually figure out what can actually work. So I'm going to plug in some test values. So I can plug in 0 here, maybe a 2.5 here, maybe a 3.5 here, maybe a 5 here. And I'm going to test these. I can test in the factored form. So x minus 2 over x minus 4 times x minus 3 greater than 0. And notice here what I want is we want positive numbers, positive results. So if I plug in 0 for x's in this expression, I would get a negative in the top. I would get a negative in the bottom and a negative in the bottom. This gives me a negative overall. Like I don't care about the values, I just care about the signs. If I plug in a 2.5, 2.5 minus 2 is positive in the top. 2.5 minus 4 is negative. 2.5 minus 3 is negative. So overall, that's a positive, right? Which is what I want. So this works. Then over here, I go over and I plug in a 3.5. That'll be a positive in the top. 3.5 minus 4 is negative. 3.5 minus 3 is positive. So this gives me a negative overall, doesn't work. Plug in a 5. 5 minus 2 is positive. 5 minus 4 is positive. 5 minus 3 is also positive. So this gives me a positive overall. And that's actually good. So I want this. So the regions that work would be between 2 and 3 and 4 to infinity. That's this option right here. Okay, solve the inequality. This is an easier inequality. So just to make sure that if anyone was confused with the previous inequality, you can actually prove that you do know something about inequalities in this program, in this problem here. So hopefully we know that what we want to do in this case is you almost treat it just like an equation in the beginning. So you'd factor. So you'd end up with from this x equals 0 or x equals 2. On the number line, you're going to test those. And here, notice you want the opposite. You actually want the negative. So you pick some random test values. Say I pick a -1. I can pick a 1 here, and I can pick a 3 here. You can pick any number you want in the interval. Just make it easy, right? So I'm not going to pick like 1,556, even though I could. Just make it easy to see. So we're going to test this in. So if I plug in a -1, that's -1 times, that's a negative times a negative. That gives you a positive, so we don't want that. If I plug in a 1, that would be a positive and a negative. So this gives me a negative overall, which is good. Actually want that. And of course, these are strict inequalities, so I can't actually be equal to 0 or 2. But I can be between these, that's fine. 3, I would have a positive here. 3 minus 2 is also a positive, so that gives me overall a positive. So I don't want that. So only between 0 and 2 actually works. And that's here. Okay, simplifying a radical. So we also know in theory how to deal with this. You want to simplify the radicals, you break each radical into 2 parts and you separate the parts that simplify from the parts that don't simplify. So for the first one, I'm going to break this up into 2 radicals. Plus here I have my a squared, my b. Break this part up into 2 radicals. And right, so now I just go through and split everyone up. So in the first radical, the 18 can split into 9 and 2. The 9 would simplify, the 2 won't. A to the 11 is a to the 10a. B to the 7 is b to the 6 and b. Moving on to the second radical, 32. I can think of that as 16 times 2. A to the 7 is a to the 6 and a. b to the fifth is b to the fourth and b. So in the first situation, these guys would simplify. The radical of 9 is 3. The radical of a to the 10th is absolute value a to the fifth. And the radical of b to the 6th is absolute value b cubed. Remember, this is when you have an even radical and an even power, you have to take absolute values because the even power is going to create a positive sign if there were a negative sign. So we have that. Here, radical 16 is 4. This is absolute value of a cubed, absolute value of b squared. Here, the absolute value of a squared times the absolute value of a cubed gives me absolute value of a to the fifth. The absolute value of b times the absolute value of b squared gives me absolute value of b cubed. And so we have that. Now I notice that these guys are the same. So it's like I have 3 apples plus 4 apples. That's 7 apples. So I have the third option here. Okay, consider the compound rational expression. What is the best expression to multiply and divide by in order to transform this into a simple rational expression? This is the LCD. So I would just realize that this here is a over x plus 2 minus b over x minus 2 times x plus 2 over c over x minus 2 minus d over x plus 1. This means that the LCD is equal to, well, looks like x plus 1, x plus 2, x minus 2. Does that actually fit? Looks like it's that guy. There's that one. Suppose you want to simplify this. What would be a good first step? Well, you could actually simplify it. So you just, you'd actually know what steps there are to take. This would be the square root of, notice that the inside is a perfect square. This is actually just x plus 2 all squared. And we know that if we take a square root of a square, that gives us the absolute value. So this actually simplifies the absolute value of x plus 2. What are the options here? Square the expression to get this. No, you can't just randomly square an expression. You're changing the value. Notice that it simplifies to x plus 2. Well, it actually doesn't. It simplifies the absolute value of x plus 2. Apply the square root to each term to get this. No, that's a distributing powers across sums error, so that's not going to work. Solve this equal to 0. No, you did not have to do that. So it's actually none of the above. Okay, suppose you know that this factors and one of its factors is 2x minus 1. What is the value of k? There are a couple ways to actually do this. You can actually just do brute force, just plug in these values for k and see if it factors. into what you're saying, or you can be a little bit more sophisticated. So one way to do this if you're let's do the sophisticated way. Like if I know that this guy factors, we know that 6x squared plus 5x plus k factors into 2x minus 1. And in order to get the 6x squared, I know there must be a 3x here. But the thing is, I don't know what the constant term needs to be. However, if I could figure out that constant term, I would actually be able to tell you what k is. So what I'm going to do is I'm going to call that another variable. Let's call it y. We need to find this. And so what you can do is you can just multiply out 6x squared. This will be minus 3x plus 2xy minus y. So I know that my k is going to be whatever the negative y value is. It's just going to be minus y. How can we do this? Well, if I factor out an x, notice that this must be equal to minus 5 because that's the coefficient of x. So this tells me that minus 3 plus 2y must be equal to 5. So that my 2y must be equal to 8, so that my y must be equal to 4. So if y equals 4, that means this part here is actually just minus 4. So that tells me my k needs to be minus 4. And you'd realize that that's none of the above. Another way, probably the brute force way. So a lot of people probably won't come up with that way. But the brute force way is to plug in each k value and force it to factor with an 2x minus 1 factor. So you can go in and you can plug in k equals 0. Right? So if you look at, say, k equals 0, this would give us 6x squared plus 5x. Now, that definitely doesn't, I mean, if I wanted to factor this, it factors into that. So no, doesn't work. Probably k equals minus 3. So if I plug in k equals minus 3, I would have 6x squared plus 5x minus 3. If I force that to be 2x minus 1 times something, so this, I force this in here, then this would have to be 3x plus 1. And you'd realize that you wouldn't get a 5x there. So that doesn't work either. Middle term not equal to 5x in this situation. So you'd go over, plug in the other one, k equals 4. Plug in k equals 4. You would have 6x squared plus 5x plus 4. If I force this to factor 2x minus 1 times something, so I'm forcing this. What that something would have to be is 3x minus 4. And again, you'd realize for the same reason, this doesn't work. Because your middle term in this case would be like minus 8 minus 3. So your middle term is not equal to this. So this same error happens. One last guy to check out, the k equals 1. If your k equals 1, you have 6x squared plus 5x plus 1. If I force that to factor like this, that would have to be a 3x, and this would have to be a minus 1. And again, does not work for the same reason. If I expand that, the middle term would not be 5x. So you'd realize that none of these options work. So that was a brute force way. Here's the last question, the 20th problem. Remember, the first problem was just the instructions and signing the honor code, whatever. So this is the 20th problem. And so suppose you wanted to factor this guy. Factor in the GCF would be the first, that would be the. So we've seen this actually a few times. So we do know that the best thing to factor out is the lowest powers of the common term. And we know that what would happen on the inside is that we subtract the power that we factored out. So if I subtract a negative third, it's the same as adding a third. So this is 5 over 3 plus 1 over 3, that's 6 over 3 or 2. 2 over 3 plus 1 over 3, that's 3 over 3 or 1. And minus 1 over 3 plus 1 over 3 is 0. So that just becomes x to the 0, which is 1. And so that's what that would look like. And that's this option here. And that's the test. So the other stuff was stuff that you could have seen. You could have known and done. They actually weren't that bad. We didn't cover them in our class at the time I gave you the test, but you might have seen them in high school or something, and you might have remembered something. And so if you remembered all that stuff, then most of the bonus problems actually weren't that bad. So let's actually go through the bonus problems. Here's a problem. I have the equation of a line. The graph is shown. Write down what the equation of a line is. And graphing equations of lines and stuff about lines is actually in the lecture that you should be watching today, lecture 14, as well as graphing parabolas. Yeah, so one thing you can realize here is that the y-intercept is -2, which means that automatically those two can't work. Definitely not those. Now I know the y-intercept, so we do want to know the slope. So what we can do is pick another point that the line passes through, like here, and just find the rise over run. So the rise is 3, and the run is 1. So the slope should be -3. We know it's minus because it's going down as you move from left to right. So that was that. Okay, let me move the other bonus problem. The other one has several parts. It's nice. It's easier if I move it from this other computer. we go. So I did the opposite. I gave you the equation of a line and you were to pick the right picture. Of course, when it comes to the equation of a line, the best way to figure out the picture, and this is in general, even if you're drawing it from scratch, would be to actually find the intercepts. So here I would just find the intercepts, they're pretty easy to find for lines in general. So for x-intercept, you set y equals 0. This would mean that you have 8x equals 16, or your x must be 2. For the y-intercept, you would set x equals 0. This would mean you'd have minus 8y equals 16, or in other words, y equals minus 2. So I know I want the y-intercept to be minus 2 and the x-intercept to be positive 2. And that's the second option. Okay, what's the relationship between the slope of two non-vertical perpendicular lines? So if they're non-vertical, it means that all the slopes are always defined. They're going to either be positive or negative numbers. They won't be 0 or undefined because neither one is vertical. So that in that case, there are two ways you can talk about the slopes. The product of slopes is -1, or you can think of that 1 is the negative reciprocal. This thing. Reciprocal of the other. So there are two ways you can kind of classify those. Those both mean the same thing. Choices here, they have the same slope. One slope is negative, the other no. One slope is the reciprocal of the other, no. It's a combination of those two, but not any individually. There's no general relationship. That's not true. It's none of the above. There is a general relationship. It's just that it wasn't here. Center and radius. So this was like on a bonus problem to another guy. Okay, Catherine's thumbs up. This you would move over here, that's 16, which is 4 squared. And so we know the R must be 4. We also know to get the center, you just change the sign of the numbers that are beside the X's. So you would change it to a +1, -2, and the radius is 4. It's this option right here. You can actually just look at this one and tell almost no calculations here. So we're about 2 minutes over time, but that's because I was blabbering on and elaborating and explaining everything. But let's just actually finish this one, and we'd finish the test and the bonuses in less time than I gave you for the test alone, but which is good. And you didn't even have to write down everything for everybody. So I think the timing was okay. So here, this is a little bit more complicated, but essentially we want to pretend that there's a circle going through here. We'd of course need to be able to find the center and the radius. So that's the center and that would be the radius. And at this point, you actually would know that the center would just be the midpoint of the given points. So the center is the midpoint of the given points. So that's going to be A is -2, 3. And the B is 4, -1. Okay, so that's just going to be, you add the x's, divide by 2, comma, add the y's, divide by 2. It's going to be 2 over 2, which is 1, 2 over 2, which is 1. So the center is 1, comma 1. Now when you want to find the radius, you now have a bunch of options since you know the center. So it's either going to be the distance from the center to minus 2, 3, or you can do this as the distance from the center to 4 minus 1, or if you don't want to, if you're afraid you made a mistake with the center and you don't want to reuse the new point that you developed, you can actually use the old points. It will be half of the distance between the minus 2, 3 and 4, 1. All of these will give you the same value. So let's just pick one. Let's pick this one. So this means that the r is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. That's 3 squared is 9, 2 squared is 4, it's radical 13. And so I know that these, so this means the circle is x minus 1 squared plus y minus 1 squared, because I know the center is 1, comma 1, and radical 13 squared, which is just 13. And that's the third option. And there we had it. 5 minutes over time to get through the bonus problems, but that's the entire test. Hopefully that was okay for everyone. It wasn't too outlandish. Everything I said was somewhat familiar if you went through the classes. Hopefully you're also keeping track of the mistakes that you made to avoid making them in the future. But yeah, that being that, we will we'll end right there. Will what be posted on the website? Well, the recording and the notes are always posted on YouTube, right, as always. The same thing is going to be done. Yeah. Okay. All right. We'll stop there. Everyone have a good rest of your day. Keep studying, keep up with the lectures. There's no quiz tomorrow, but don't use it as an opportunity to slack off. Actually use it as an opportunity to go over your mistakes and make sure you're doing, you're correcting them moving forward. That being said, we will end there, and I will see you guys in the next one. Ciao.